Hello and welcome to Math for Today. As you now see, we did not do the morning math review. There's a couple people that still need to do that. So check your inbox because that will give you a reminder if you need to do it or not. You probably know already if you did it or not. There was a couple that were to be marked by me. So I'm doing that today because I know that not everyone is quite finished. So I will do that today so you guys can kind of check back probably by the time that you're done today's lesson to see how you did on that, or maybe even before you even do the homework right after you finish watching this. So okay, plan for the week is we're doing our show what you know for this unit on Wednesday, and then we're going to be done this unit, which is pretty awesome. And really good job, pat the back, because this is not an easy unit to do. I was honestly really hoping that we'd be back in class so that we could do this one, because I think it's one of the hardest of grade 6. But also you guys have done a really good job with it. So yeah, excellent work. So show what you know is on Wednesday, and then we're going to go over it on Thursday. So that's like just so that we can have this all kind of tied up before we go into our eat break. So basically that means the next couple of days are going to be busy for us because we're finishing off the very last topic. It's not that hard. You guys will get you'll get a very, very, very good gist of it today. Today is the easy stuff. And then like the questions that I'm giving you today won't quite be like, there might be like one question that's just easy on the show, you know, at the end. But over the next couple of days, especially basically tomorrow, I'm going to be showing you, some of the harder stuff that would like actually be on the PATs, even though we're not doing them. Okay, so here we go. You need to have out your notebook, and we're writing down a new topic today, which is this. So today's date at the top, which is May 17th already. I can't believe it. The title is Preservation of Equality. And this is the I can statement. I can demonstrate and explain the meaning of preservation of equality. Okay, so today we're actually going to be doing both of those parts. We're going to be explaining what that means, preservation of equality, and we're also going to be doing it a little kind of like taste into demonstrating it today. So preservation of equality. Okay, well, what does that even mean? So if we were in class right now, I'd ask you guys, okay, what does that mean? So think about it. What do you think that means? Preservation of equality. Okay, see if you can kind of like have some ideas already going in your brain as we go through this. Okay, so first of all, so equations we're going to be working with. So this is just a kind of reminder. If you don't want to write this part down, you don't have to, but it's still kind of a good reminder. So an equation is when we put two expressions together, right? So an equation has to have an equal sign. So this down here would be an example of an equation, right? There's an equal sign. So both sides must equal the same value. Okay, so both sides equal the same thing. That's why that would make sense that we have an equal sign if they are actually equal. Equations also should have an equal sign. Okay, so it's different than an expression. And then there also should be operations on both sides. So something like, these are a little bit more complicated than what we saw last week, because last week we saw something like 4 plus y equals 5, then we'd have to know that y would equal 1. But now these ones this week are going to have like equations or operations on both sides. So the key thing to think about with this, okay, so here's an example. Here's another example of an equation, right? 3 plus 4 equals 10 minus 3. So those are very, very, very simple basic facts, right? If we just solve this, we know that 3 plus 4 is 7. And then we know that 10 minus 3 is also 7. So yeah, those two sides are equal. So the way to think about equations is like two friends, right? If these girls are going to eat some burgers, this girl has 4 for lunch, 1 for dinner. She's had 5 in the day. This girl had 2 for lunch, 3 for dinner, 5 in the day, right? So you have to think that both sides want to have the exact same amount. That shows that the equation is balanced, or the equation is equal. Okay, so basically equality has been preserved. Okay, so this is the preservation of equality thing. Equality has been preserved within the equation when both sides of the equation equal to the same amount. So that's not really too crazy of a concept, but that's basically all that it is. That's what it means. That's the explanation. When both sides of the equation are the same. Okay? Hopefully that is easy enough for you to grasp. Okay. So, all right. Now the next thing is there's different types of equations. So the goal is to have a balanced equation. We want to have, this is like a scale. This is kind of like a really easy way to think about it. We want to make sure that whatever we have on one side is equal to what we have on the other side. And when we have that, we have a balanced equation, or we have preservation of equality. The equality has been preserved on both sides. It's true that we have an equal sign here. Okay? So basically, balanced equation is when both sides have, okay, right. So you might get a balanced equation is when both sides have already been solved for you. Or, dun dun dun, this is what we're going to be mainly doing, is an unbalanced equation. So this is what you're often going to come across. They're going to ask you to balance it. They're going to give you something that's not balanced. Like right now, we don't know what this question mark actually stands for. So your job is to balance the equation. So to do that, this is basically, for now, for today, it's basically just like basic facts. So 11 plus 3, obviously 14, and then 8 plus what gives us 14? Well, we know in this case, the answer would be 6. So this question mark is just like a variable. Sometimes you'll see a question mark, sometimes you'll see an X, but basically it's the same thing. You just got to figure out, well, what's that amount? How much is it going to be equal to? So in this case, it's just 6. Okay, hopefully we're okay with that. To practice this, we have 2 different stages of homework today, okay? So the first stage is a seesaw task, which I'm just going to show you right now. Okay, it looks like this. How can I do this? Assign. Okay, well, whatever. You guys will see this pop up. Okay, yeah, assign. Alrighty. Okay, so basically this is it. Okay, so here's the example. They start off a little bit easy. If it has 1 star, it's an easy one. Then it's going to get more challenging. So you just have to figure out what is on the line. I've left lots of space for you to write this in. So with the example, this is a harder one. 67 minus 21 is 46, okay? Then 45 plus what gives us, we know the answer has to be 46. So you just figure out what's the missing part. So this one, okay, hopefully you can figure this out without me having to tell you. Be careful that when you're doing this, there are, there's 4 pages, okay? But there's like seriously like 2 questions on each page. So it's just kind of like, it's hopefully not gonna be that challenging. So, yep, you might wanna solve this part first, okay? Then what does this equal? So starts off easier, and then this one gets a little bit more challenging, just like a little bit harder basic facts. And then this one would be the most challenging, okay? It just basically is working with larger numbers, okay? So there you go. That is the first portion of today, okay? So we are going to do, I don't know why it does this. Okay, so hopefully that first part kind of makes sense, okay? I don't think it's gonna be too tricky for you to do. And this next part is like also kind of an easy thing. So we're doing like 2 kind of like mini things together today. So that was the first part. The second part is learning about one more thing. And I know this is like, it's kind of a little bit of writing for you today, but it's gonna be the most of the whole week. The next thing that we're gonna be doing a little bit of practice with today is this simple thing. It sounds all fancy schmancy, but it's actually so easy. It's like, how is this even grade 6 stuff? It's called the commutative property. Commutative property is basically says that when changing the order of the numbers, the result does not change. So for example, when changing the order of the numbers in an equation or on one side of an equation, it does not change the result. So does this work for addition, subtraction, multiplication, and division? If we just go back to your basic facts. If you did 5 plus 3 and then 3 plus 5, would that equal the same thing? Yes, right? So that would work. How about subtraction? What if we did 5 minus 3, and then we flipped it 3 minus 5? Would that still be the same thing? No, right? It's really important in subtraction and division that you have the larger term first, right? So it does not work to flip them around. How about for multiplication? Does that work? 3 times 4 is the same as, 4 times 3 is the same as 3 times 4, right? Like, we know that we can flip them around. So basically, does this work for all of these 4 operations? No. It only works for addition and multiplication. So you're going to be asked a question of like, what shows the commutative property? And they're going to give you like an addition question, a subtraction question, a multiplication question, division question. You're going to have to pick out which ones actually work. So it's just like, you kind of just like, you just know it. Like I probably could have given you these questions before even sort of explain this. You're like, well, of course we can't flip 7 minus 4. It's not the same thing as 4 minus 7, right? You have to have the bigger number first. So that's it. That's the commutative property. So it's pretty simple. It works for only addition and multiplication. So the second part of the homework today is practicing that. So it's on page 35, questions 1, 3, and 5, okay, which I'll show you that have to do with the commutative property, okay? So there's 2 like kind of easy things for today. So this is page 35, okay? So here we go. Suppose that you're using real balance scales. Which of the scales below would be balanced? How did you find out? Okay, so I'm not going to explain that one anymore. You just have to say yes and then explain if it doesn't work, explain why. We're going to skip number 2. The next one is rewrite each expression using a commutative property. Okay, so easy, right? Like for that one, it's just like, you just, like, it's so easy, right? Like it's kind of crazy. It's grade 6. Commutative property. Flip the numbers. So easy. It's like a freebie kind of question when you get one of these on a test. And then number 5 as well. So addition and subtraction are inverse operations. Addition is commutative. Is subtracting commutative? Use an example to explain your answer. Okay, so that's basically what I just sort of went over. So that's it for today. Hopefully you guys are okay with that. So it shouldn't be really too challenging. Okay, so that's it, just this. And then please make sure that you have done the morning math. That is the number 1 priority. Okay, good work. And yeah, have fun with this and then see you soon for ELA. I bet you can finish this before ELA time.